Hi guys, and welcome to the second video for this lesson, the sector area of circles. So in this video, we're going to learn to find the area for a sector of the circle. We could use this to compare prices of foods like pizza that are made up of circles, and you'll know you're successful when you can find the area of a circle, sector area of a circle using the formula. So remember that the area of a circle is the physical space that it covers. The formula to calculate it is pi times r squared. Okay, and we're going to need that formula because it integrates directly into the formula for a sector, the area of a sector. A sector, however, is a portion of a circle's area that is formed by a central angle. To calculate it, we use the following formula. So what I mean by that, before I get into the formula, is this area in here, this area, okay, not the arc, that area is considered the sector of the circle. It is the physical distance covered by a portion of the circle. So to calculate it, we're going to take, and I don't know why we use like a cursive S, but if you don't want to use a cursive S, that's okay. Just use a capital S. S is equal to the area of the circle multiplied by the central angle measure divided by 360. Where have we seen a formula like that before? Oh, we saw it in the last portion of the section with circumference. So this is, again, part of a circle, and we used the degree measure to set up the portion of the circle, the fraction of the circle that we're calculating for. So let's take a look at some examples. What is the area of the shaded region below? State your answer as exact and approximate. Okay, so I have everything I need. I have the radius, so the radius is equal to 8. I have a central angle degree measure, so I can just jump right in. I'm going to start off by calculating the area of the circle. So the area of the circle is r squared times pi. So r squared times pi, r is 8, so I'm going to put in the 8 there, times pi, and I get 64 pi. Oh, my equal sign went a little too far. 64 pi. So I'm going to take that calculation, and I'm going to put it into, and I don't really have a unit, so I'll say unit squared. I'm going to take that calculation, put it into the sector area formula. And I can't really do the cursive S on my with my mouse here, so I'm going to use just a capital S. So the area is equal to 64 pi over 1 times 60 over 360. So now what I can do is go ahead and multiply just the two top coefficients like I did in the last one. So 64 times 60 is 3,000. So the sector area here, and that is a horrible S. So S. The sector area is 3,840 pi. Don't forget the pi, attach the pi at the end, divided by 360. So the sector area, when I reduce my fraction, so 3,840 divided by 360 is 10.6 repeating. So as a fraction, it's 32 pi over 3 units squared. So remember that because it's still an area calculation, area is always squared. So then that's my exact answer. So if I want to approximate it, I would say that that's approximately, so 32 divided by 3 times pi. So I know that you guys can't see it, but I'm using my calculator in order to make these calculations. So multiplying 32 by pi and dividing by 3 gets me an approximate sector area of 33.5 when it is rounded units squared. So let's take a look at the next one. What is the area of the shaded region below? State your answer as exact and approximate. So I have the arc measure of 80 degrees, so that directly translates to the inside central angle being 80 degrees as well. So then what I am going to do is calculate the area first, like I did last time. The area of the entire circle is 4 squared pi feet squared, because they actually do give me a unit here. I need to use their unit. I rewrite my F. So then the area is equal to 16 pi feet squared. So I'm going to take that and plug it into my sector area formula of S equals 16 pi over 1 times 80 degrees, because that's the central angle measure, divided by 360. So I'm going to multiply on the top. 16 times 80 is 1,280 pi. So I've got 1,280 pi divided by 360. So then, yeah, I will go ahead and divide 1,280 by 360. And I get 3.555, like repeating. So turning that into a fraction, the best reduction of me pushing my math fraction key is 32 pi over 9. And that's feet squared. And if I do the approximation, 32 divided by 9 times pi is equal to 11.2 feet squared. Okay, so now we're going to work backwards. The shaded region below has an area of 27 pi units squared. What is the measure of the central angle that creates the shaded region? Okay, so we still need to calculate the area of the circle in order to work backwards here. So the area is equal to 9, the radius, squared times pi. So the area is equal to 81 pi units squared, because they gave me units squared for the original problem. So I'm going to substitute that in my sector area formula. The sector area here is actually known to be 27 pi. Okay, we know this. Sector area is S is equal to 81 pi over 1 times x degrees, because we don't know how many degrees, divided by 360. So we're going to get 27 pi over here equals 81 pi x times x divided by 360. And so we're going to go ahead and, because we have a fraction on one side of the equation, we're going to turn the other side of the equation into a fraction as well. And then we're going to go ahead and cross multiply in order to make this a solvable equation. So I do 27 times 360, and I'm going to attach a pi to it at the end. I get 9,720 pi, that's 27 times 360, and attaching the pi equals 81 pi times x. So to solve for x, I'm going to divide both sides by 81 pi. And because there's a pi on both sides, what's going to happen is I can just cancel them out right away. And then I'm going to end up dividing both sides by 81, which gives me x degrees. And so I'm going to do 9,720 divided by 81 and get 120 degrees. And finally, a real-life example. You bake a delicious pie. The pan it is baked in has a diameter of 10 inches. You cut the pie into 6 equal slices. What is the amount of pie that you get per slice eaten? So, what we're going to have to do is start by drawing a circle. And then we're going to, I didn't want to draw a circle again. we're going to cut the pie into 6 equal pieces. There we go. My measurements are a little more equal now. What is the amount of pie that you get per slice eaten? So we're going to go ahead, and we know that the diameter is 10 inches. 10 inches. So that implies that the radius is 5 inches. And we're moving directly to that measurement because we need the radius for the area calculation. Area is equal to 5 squared times pi. So the area is equal to 25 pi inches squared. Okay, what I'm going to do with that information now is I'm going to take 25 pi and put it into the sector formula. S is equal to 25 pi over 1 times x degrees over 360. We do know the actual degrees. If we take 360 and split it into 6 equal parts, we get 60 degrees. So if we take 360 and split it into the 1, 2, 3, 4, 5, 6 equal pieces, each piece is 60 degrees of the circle. So then S is going to be equal to 25 times 60 pi. So 25 times 60 and attach a pi at the end. 1500 pi over 360. So S is going to be equal to 1500 divided by 360 is 4.16 repeating, and as a fraction that would be reduced. The fractions here would be reduced to 25 over 6. So 25 pi over 6 inches squared. Now, again, because we're talking about the real world here, we want to express our answer as an approximation. So if you multiply 25 divided by 6, or if you take 25 divided by 6 and multiply it by pi, your approximate answer is about 13.1 inches squared. So inches squared. So that wraps it up for sector length, or sector area, guys. It's very similar to arc length, mainly because they both share that theta divided by 360 portion of the formula. Instead of a portion of the circumference, though, we're finding a portion of the physical distance covered by the shape. Sector area could be compared in real life to things like a slice of pie or a pizza. And don't forget units, since we are calculating area. So that's it for today's video, for the video lesson, guys. Thanks for watching, and I'll see you in the next one.